Hello everyone. Today we are going to discuss about analysis of variance ANOVA. It is defined as a statistical method used to figure out if the average values of different groups in a sample are the same or if there are significant differences. It comes in handy when you are dealing with more than two groups. Essentially, it helps us understand whether the groups are similar or if there is a significant distinction between their average values. Its assumptions are normality. In this assumption, variable is dependent and distributed within each group. Homogeneity of variance. Homogeneity of variance suggests that the groups you are comparing have a similar amount of variability. If this assumption is violated, it can impact the accuracy and reliability of the statistical tests. And independence. Observation within each group should be independent of each other. The components null hypothesis has no significant differences between group means. An alternative hypothesis, at least one group's mean is significantly different from the others. F value is representing the ratio of between group variance to within group variance, and p value is observing an F value as if the null hypothesis is true. And its interpretation is if p value is less than predetermined significance level, reject the null hypothesis in favor of the alternative hypothesis that concludes there is a significant difference between at least one pair of group means. If p-value is greater than the significance level, there is insufficient evidence to reject the null hypothesis and no conclusion can be made about the differences between groups means. So overview of this assignment is the dataset we are working on is extracted from the National Survey of Children's Health, which is conducted by Centers for Disease Control and Prevention of CDC and the National Center of Health Statistics. Task we deal with in this assignment is downloading the sample data from this National Survey of Children's Health website or the data code that has given in the assignment, and we have to extract a construct a subsample in that and summarize the data, then examine the effects of various factors on chronic health conditions, that is dependent variables, by performing statistical analysis. ANOVA. And the initial step to create subset, we should understand the factors affecting the chronic health conditions. As described, we should exclude data from the children aged from 3 to 5 years. And here there are two variables actually, dependent variable and independent variables. Dependent variables is directly dependent, which are chronic health conditions and conditions related to health like arrhythmia or genetic conditions, etc. And independent variables is consistency of health insurance coverage and poverty and basic needs, adverse life experiences, etc. These are the steps that we do. First we have to prepare the data, that is data preparation. Then we have to summarize the data, and the data after after summarizing, we have to do the statistical analysis on that data. Now we will work the R code. So I'm working in the R markdown. Here we have the we have to install the packages like Heaven, Mass, Broom, and TDverse. Heaven package is used to read data file, and Mass is for the data transformation to normalized distribution, and TDverse is used for data manipulation, that is for plotting dplyr and TDR, and Broom is to get the test output. After that, we have to load the libraries. Here I have loaded the libraries as shown. Then we have to load the data that we have extracted from the given site in the assignment. Let me This is the following data file. We have to download the data file and unzip it and load the data. Here we are using the function read underscore DTA, and we are assigning a value to the df. So here this is the set. There are 463 variables and more than 50,000 children. That is, age varies from the 0 to 17. In this whole data, we are differentiating the age group of 3 to 5-year old children. So we have to prepare data according to that. Here, data only for the children is 3 to 5 years old. We are using the function like filter function. We are describing the age of the children which is greater than or equal to 3 years, or and age of children which is less than or equal to 5 years. By using this function, filter function, we obtain the so I have to do this from the first. For this, we have to load the data. And this is the data we got from the following data frame. Then we have to prepare the data. Again, we have to run this code, which will give the output here, which is showing less number of people than before, which was previously we had 50,000 members and 463 variables. The number of variables hasn't changed, but the number of members have changed because we have differentiated 3 to 5-year old children. Then we have to select only relevant columns to retain. So I have selected following variables, that is age of the children, race of the children, and how often has it been very hard to cover the basic needs like food, shelter, etc., and sex of the child, and health insurance coverage past 12 months. And these codes which is assigned to the following condition or following variable preventive visit, that is how many times they have visited for the hospital. And these are the health conditions, which are allergies, arthritis and blindness, blood cavities, concussion, coordination, cystic fibrosis, Down syndrome, dressing, alone, that is mental one of the mental disorder, and genetic disorders, memory conditions, sickle cell anemia, and toothaches, etc. And these are the codes which we have assigned to the following variables here. This can be extracted from the given assignment. Surely in the data dictionary which we have in the assignment. Yeah, let me share, open the website. Yeah, now I'm going to open the assignment. Here we can see the given data to us for the completing this assignment. Here there is a data dictionary PDF which we will download and able to see each code and its variable given assigned to it. Then after this we have to give the subset to the data from the columns to keep. Here we are using the function dpl where select all of the columns to keep, and for this function is that after giving this function we have to recode the column, so that we have to convert this into the binary column so we can add all the variables and number of conditions, get the sum of number of conditions as a numeric. Then here we can see the removal of one of the column. Here one of the variable is removed in this subset. Then we have to create a new column for num conditions, that is number of conditions, and to obtain the sum of all condition columns. Here we are using the function row sums, and we are taking the subset we have obtained before, and we are using the function row sum. In the end, here at the end of this row we can see the variable num conditions attached to this new subset, and this is sum of all the conditions. Then after obtaining the required data or subset, we have to summarize the data. Then we have to first step, we have to convert the categorical variables to the factors by applying the function mutate function across age, years, and num conditions as a factor. Then we have to see the summary here. You can see that is from minimum to maximum, and this is for age, that's minimum from 3 years and maximum for 5 years. And these are the cavities, number of children got no is this many, and S is this many, that we have assigned the binary code for S and no in the before. These are the obtained data, and the number of conditions is minimum 0 and the maximum is 27.0. Here we have obtained the mean, which is 0.9545. Then we have to start the analysis by using graphs. That is, first we have to use ggplot to see if the data is normally distributed visually. We have applied the ggplot function as is here, and the output we got is this graph. From this graph we can say that data is not normally distributed. And next again we have to confirm it by using qqplot, and the functions we use it for the qqplot is qqnorm and qqline, and the number of conditions field is not normally distributed. From the graph you can see here. To prove this, if it's normally distributed, the line should be diagonally represent diagonally, and then we have to use login transformations by log transformations. Here for the log transformation we use the function log1p, and here you can see the log num conditions have assigned to log1p. This is the formula, and visualize the transformed data by histographically. Here we can see the data is not normally distributed. Then we have to use the box transformation. Then we have to add a small constant to measure all values are positive. Then For that function, we have to add num condition positive assigned by +1, and then we have to use the box cox function to the data given. Then after assigning this data subset to the num conditions, we can visualize the transformed data by, again, histographic representation. The following graph is obtained from the function we have used. Therefore, we can prove that data is not normally distributed. Then even though it is not normally distributed, we should work more on t-test and ANOVA analysis. Further explanation is done by Nitya. Thank you, everyone.
Hello everyone. Now I am going to explain about the second part of the first question from the ANOVA assignment. From the first part of the question, we can say we come to know that the data could not be transformed to obtain the normal distribution. So there is no need to perform the t-test and ANOVA analysis. But for the sake of the practice, and for the assignment purpose, we perform the ANOVA test and t-test. We use the t-test if there are only two categories in the independent variable, and the ANOVA analysis if the independent variable has more than three categories. Here we perform the t-test for gender as it has only two categories, which is male and female. Here we use the t-test function of the R to perform this test, and the formula consists of the dependent variable, the independent variable, and the data subset. And then I also plotted a box plot to show the difference between the difference between the means of both the groups. Then we use the print function to get the results. Here we get the box plot which shows the group 1 which is male and the group 2 which is female, and then we also have the p-value which is not equal to 0 and is very small, which means that there is significant difference between the group 1 and group 2. And the mean value of group 1 is greater than the mean value of group 2. Then we perform the ANOVA for all the other variables, as these have more than three categories in the independent variable. So we perform the ANOVA test for these variables. To perform the ANOVA test, we use the AOV function of the R. The formula consists of the dependent variable, the independent variable, and the data subset. Then we use the print function to print the results of this summary. When we print the results, we get it as this, which has the F value and the P value. Then we use the same AOV function to perform the ANOVA for the independent variable AS1, which means hard to cover, which means the children who are having difficulty to cover the basics like food and housing. Then we print the summary, we get the results as the same as the previous one. Then we use the insurance coverage. We perform the ANOVA for the insurance coverage gap. Here also we use the same AOV function. And the formula consists of the num conditions, which is the dependent variable, the insurance gap, the independent variable, and the data subset. Then we print the results. We get results as this. Then we use the same function for number of preventive visits, which is denoted by K4Q20R. Here we use the AOV function and the formula consists the same as previous, the dependent variable, the independent variable, and the data subset. Then we print the results. We get the results same as the previous. Then in the last part of the assignment, we need to create the tables for all the test results. To create these tables, we need to convert this text into the data format. So we use the broom package and the tidy function and also the mutate function of the R to get the data format of all the tests. When we run these functions, we get the results in the environment. Here the data is show. Here we get the data format of the function we run. Then we perform the same function for all the independent variable tests, that is t test for the sex, ANOVA for the race, ANOVA for the ACE1, and ANOVA for the insurance gap. We get all the results of all the tables of these test results in the environment here. Then we need to combine all the test results by we combine all the test results by using the bind rows function. When we run this function, we get a table as this, which has values significant for t-test and values significant for the ANOVA also. To get the values which we need to use the subset function and choose the values which we want. We choose the test, the variable statistics, df value, and the p value. Then we use the interpretation function to get to show the p value if it is whether it is significant or not significant. When we run this test, when we run this function, we get the results as this: the t-test for gender, the statistics, the test, the variable, the statistics, the df value, the p value, and the interpretation results. Thank you. This is the end of the first question.